Today we're going to do the Unit 3 review for properties of triangles and triangle congruence. I'm going to cut it into different videos so it's not one entire long video. So we're going to start with number 1. Determine if there is enough information to allow someone to create a triangle congruent to triangle XYZ. Now if you notice on your review sheet, the 30 degrees is out here and it should be inside the triangle. The little box to show that that's a right triangle is up here and it should be down here. So you can go ahead and fix that. And since we know this is 90 degrees and 30 degrees, if we subtract those from 180, we get 60 in our other angle. So now you're going to go through each one of these and see if there's enough information to prove that they're congruent. So first we need to remember our triangle congruency statements. So we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So as long as it proves one of these three, then it can show that it's congruent. So for the ones that don't have a picture, I'm going to go ahead and draw a little side picture. So for A, we have a right triangle. I'm not going to worry about lettering them. A right triangle, so we know this is a right angle. One angle measuring 30 degrees. And one side measuring 12. Now, I went ahead and put the 30 degrees here, but it just said one angle. It didn't tell me which angle. And it's not telling me which side is measuring 12. So the 12 could be here, it could be here, or it could be here. So without knowing where exactly the 30 degree angle is and where the 12 measured side is, we can't say that it's any of these. So that would not work. Now for part B, we've got our right angle, our 30 degree angle, and our 12 unit side. So we have an angle, and a side, which matches this angle, angle, side, which matches this triangle congruency statement here. So that is an answer. For letter C, we have a right triangle. So we'll label this XYZ. Said XY, which this was a Y here, is 12 radical 3. YZ is 12 units, and XZ is 24 units. So we know that these sides are congruent, these sides are congruent, and the hypotenuses are congruent. So we have side, 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 so that does work. And then our last one is on a grid here. So if we make our grid, 0, 0 is right here, so that's our Y. 0, 12 radical 3 we'll put up here. So we know this length right here is 12 radical 3. And then we have 12, 0, so we know this length here is 12. Now if we use the distance formula from this point of 12 radical 3, 0 to this point of 0, 12, oops, I did those backwards, 12, 0, and 0, 12 radical 3. Then we can find the distance of this, which we would get 24. So again, we have side, side, side. So another one that works. So out of these 4 options, 3 of them have enough information to allow us to prove that they are congruent triangles. All right, let's move on to number 2. What is rigid motion and what transformations are considered rigid? So we have 2 questions here. First, what is rigid motion? Rigid motion, and we talked about this when we did those review questions the other day. Rigid motion maps line segments to congruent line segments. So that's all we're going to write. A rigid motion maps line segments to congruent line segments. Now the second part of this question is what transformations are considered rigid. So the transformations that are considered rigid are translations, when we just slide our shape over. our rotations, where we just turn the shape, and our reflections, where we are flipping the shape. So those three are considered rigid. They keep our line segments congruent. Therefore, we have congruent shapes. Number 3, classify this triangle. So we have the 3 angles of a triangle, and we need to know whether it's obtuse, right, isosceles, or scalene. So if you notice, obtuse and right are by angle measure, isosceles and scalene are by side length. So first we need to find out what these actual measures are. So if you remember the triangle sum theorem, the sum of all angles in a triangle equal 180 degrees. So we're going to take these 3 angles here and add them up and set them equal to 180.